Hello, everyone, and welcome to this short episode of Math Class with Cats. So, the reason I'm talking about this is it has a very important but subtle bearing on a lot of things that we hear in our daily lives. So, I kind of wanted to explain how that can skew our perception of what's really going on and maybe lend some idea to right and wrong ways to use these. So, mean is basically just the average. It's often used interchangeably. So, all it is you add all the numbers in a list and then divide them by the number of numbers in the list. And you can see a couple examples there. The median is you sort a list of numbers and then pick the one in the middle. If it has an even number of numbers, then what you actually do is you average the two central numbers. So you can see an example of that there. So why this is important and interesting. I'm sorry, I'm holding my webcam. These are both different ways of trying to measure the center of a data set. And you'll often see them presented in things like, oh, the average income has blah, 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 blah since year whatever. Or the average cost of whatever thing has done whatever since 1990. Things like that. So the important thing to react to here, the important thing to understand, besides that my cat is adorable, of course, is that they sometimes are the same, but how they treat outliers is different. And in my infinite wisdom, I kind of covered the example. So, this is pretty important to have a concept of because outliers really can impact the mean or average. And you can see an example on the slide, right? When I throw 20 into that range 2 in place of 9, the mean increases, the median does not change. When I have the super closely clustered set in range 3, the mean and median are very similar, as they should be. When I have an even crazier set in range 4 than I did in range 2, the mean and median look like they have literally nothing to do with each other. They aren't even close. Right, Gabby? They aren't even close. So, that has important effects on how we need to use these. For tightly clustered data sets, it doesn't matter for the most part. Both can be meaningful or meaningless depending on the quality of the data, and that's fine. But for data sets that have a wide range, or even more importantly, have outliers on one side or the other of the data of a sorted list, right? That means that usually the median or mean will be a better representation of reality than the other, right? It'll be one or the other, not both. And which one you want depends on a lot of things, and I will mostly leave that to a math teacher. But here's where I was going with this, and I'm sorry to take my cat away from you all, but I'm going to set my webcam back down, thus making you all motion sick. So the important thing here is it can actually be used against us when we start to view median or mean as an absolute truth when it's not the number that should probably be used. So here, this left chart, which I'm now covering, is taken from the Social Security Administration's website, and all it is a chart of wages. So this is not total compensation, so it doesn't include all of the benefits. It's theoretically just wages. And it shows the median and average and the change in those two over time. You can see that over time, these two numbers have grown farther apart, just in literal distance. On the right side of the graph, the average is higher compared to the median. The gap between average and median is larger than the gap between average and median on the left side of the graph. And in this case, I'm not talking about the ratio. So that is interesting because it tells us all of our outliers are at the top, which makes some sense because you can theoretically make less than $0, but that's not going to be a number that appears in a graph that only talks about wages, right? So when you're just talking about wages, you've got 0, and you can have a ton of people at $0. That is, well, not fine, but that is reality in some situations, or maybe somebody who appears to have wages of $0. So that means that you can have a cluster at the bottom, but it's very difficult to have a cluster at the top, meaning the Jeff Bezoses of the world that throw off our mean here for wage, well, he might not be the best example because this chart is only talking about wage, but you know what I'm getting at. An extremely high wage earner has an infinite range of numbers to occupy a later spot in our sorted list, such that they are an outlier way off the end of any reasonable graph that would ignore them. So our average can be brought up higher by these outliers at the top, but the mean is much less affected by them. So that's why these two lines can grow at different rates to each other, and they have. And I'm going to mostly leave my opinion on what this means for our overall economic health out of this video because it's too damn depressing. So, similarly, the idea of net worth. Basically, if you had to start selling stuff off, how much you could get, right? What's your financial value, if that makes any sense. So this also carries a breakdown by age, which is deeply concerning to me. But again, ignoring that because it's too depressing. So we're just looking at median on the left or in the middle column and then average on the right column. You can see here that in every single one of these columns, the average, or rows, the average is higher than the median. That is, again, because our outliers are at the top. So it is not meaningful, clearly, to discuss something like average wage, because if you had one person making the equivalent of everyone else in the United States, the average would look way higher than it actually was for the typical person. The typical person's experience is more reflected by median in this case, and this is just an example. Again, I'm leaving the rights and wrongs predominantly to a professional, but this is one example where the median is far more meaningful because you, me, my cat, we're having closer to the median experience, most likely, than we are to the average experience. So that's an extremely subtle thing that is, well, frankly, it's used against us to think that something is improving. For example, the average wage has been growing faster than the median wage. So if you say, oh, the average wage has improved so much in this number of years, it sounds great out of context. When you put it in the context of median wage, it does not sound as great. And then when you put, which I will definitely save for some other time when I can handle it, so presumably I will have been drinking. If you put all of that in the context of inflation, then it looks really bad. So, again, the general point here is that these two extremely basic mathematical concepts that we were all probably taught very early on in our educations, and many of us thought that it was meaningless or we would never have to know. Well, it turns out that it's important to know. Just in general, knowing things like this and watching out for red flags of how it can be used against us is extremely important. And I'll probably talk about a variety of other things that maybe aren't how they seem in another video. But for now, you guys have a good one, and I will see you in the next video. Hello, and welcome to 1 a.m. math class. That's not right. Next is, geez, I can't type, can I?